Can you guys hear me? Just before we start, please confirm that you guys can hear me. Perfect. Okay. Sorry for being late. It's just the first lesson got delayed and then just had a ripple effect to the rest of the lessons. But we'll try and continue just to try and catch up the minutes that we missed. Okay, so let us continue from where we left off last time. Perfect. Thank you, guys. Okay. On YouTube, everything is fine. You guys can hear me clearly and see my screen. Okay, so we're going to continue from where we left off last time, right? So just to remind us what we did last time, we finished up on rules of exponents. We did the previous topic. I think we were finishing equations and we did like the denominator thing. I think restrictions on denominators. Okay. Now we are going to be continuing with then we did exponents. We talked about the fractional exponent and we did some questions to simplify this exponent. Okay. Now we're going to move on and we're going to discuss surd rules. Okay, then we're going to move on to discuss more things. Okay, so firstly, we're going to discuss the rules of surds, okay, that we need to know. So rules of surds, first of which is rule number 1. Okay, if we have root A times root B, this simplifies to root AB. So we can put it all under one surd, essentially is what we're saying. Okay, for those of you who don't know what the surd is, last week some of you asked, it's basically the root, okay, like the square root or the cube root or whatever, right? In this symbol, we refer to as the surd. So yes, that's what I'm talking to when I say surd. When I say surd. Now, when I have root A times root B, I can write it all under one root as root A times B. So similarly, working backwards, if I had to have root 12 times B, I could simplify this as root 12 times root B. Okay, then if I had, this is rule number 2 now. When I have root A over root B, okay, root A over root B, so 2 separate roots. So here we had a multiplication, here we have a division. Okay, so 2 roots divided by each other. Okay, I could write them all under one root. Okay, and write it as a fraction. So it's going to be, for in this case, root A over B. Similarly, okay, working backwards, if I had to have, what is the value of root 25 over 16? Okay, I could simplify this to root 25 over root 16. And get my final answer, I can actually simplify because root 25 is 5 and root 16 is 4. Okay, let's look at rule number 3. Well, it's not most of a rule, but it's not exactly a rule. It's just like I don't know, English. Okay, it's basically telling you that you cannot simplify if you have. So because you have root A times root B, right? That can be simplified when it's multiplication. Okay, and you're multiplying it to you can simplify it all under one surd. Okay. However, when you have root A plus root B, please do not simplify this to root A plus B. This cannot be simplified. This root A plus B, this cannot be simplified. Okay, so do not make it root A plus B all under one surd. Okay, then there's just a quick thing here for us to know. It's important to know because I can ask it pretty often. But what if we have a surd inside of a squared binomial? Okay, so we have A plus root B and the whole thing squared. So it's a binomial, meaning 2 terms, okay, a binomial squared, right? Remember, what do we do to solve that? We use something called FOIL. First, outer, inner, last. Okay, and we solve it accordingly. So how I did it was, okay, so yeah, I just opened up the bracket just to open it up twice because that's how it would be simplified. And then I utilized the shortcut. Okay, so I'm going to utilize the shortcut. Again, you can FOIL it or you can utilize the shortcut. Both are going to work perfectly okay, right? So what I'm going to do is I'm going to say A squared plus 2AB plus B squared. Okay, so a squared, so remember this is my a, this is b. Okay, so a squared is just a squared plus 2a, which is a, b is actually root b plus b squared, so square root b squared. When I simplify this, I get a squared plus 2a root b plus b. Okay, that's just to simplify. However, you can write it out like that as well. Okay, so that's just foiling a surd. Why can't it be simplified? Because that's the rules of surds. It doesn't simplify as that. You're not going to get the same answer basically. Square root a plus square root b is not going to be the same answer as square root a plus b. So you need to memorize the rules of surds to know which ones work. So only multiplication and division you can simplify the way we did. Okay, that cannot be simplified because it's in its simplest form. It cannot be expressed differently. You'd have to get the value of this and add it to the value of that. There's no like shortcut to simplify it like this, for example. This simplified to that. Okay, but this is in its final form. Okay, it's like unlike terms almost, like how you have, if I have x squared plus y squared plus 7, there's nothing I can do with that. Okay, I can only, that's in its most simplified form. Okay, so that's what I mean, not simplified. Let's talk about simplifying surds. Okay, so simplifying surds without a calculator, that is, by the way. Okay, in order to simplify a surd, you need to take the value inside of the surd and you need to write it as a product with a perfect square. So firstly, product, we're talking about multiplication. So you need to break down 50 into its factors, because that's what, when are we going to start trig? Probably next week. If we can finish everything allocated for this for today, then we'll start trigonometry next week. Okay, we need to break down 50, write it as a multiplication with a perfect square. Now, what are our perfect squares? Remember, our perfect squares are 1, firstly, because 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on, right? So if I want to write 50 as a product with a perfect square, if I want to basically write factors of 50, but one of its factors has to be a perfect square, all right, can someone tell me, how can I write 50 as a product with a perfect square? How can I write 50 as a product with a perfect square? So basically, what times what gives me 50? And one of those factors have to be a perfect square. So essentially, you are taking one of your perfect squares and multiplying it by something to give me 50. So how can I write 50 as a product with a perfect square? Anyone? No one. Really? Okay, 1 and 50. That's fine. Okay, but that's not going to change anything because you wrote the same thing. Okay, so 10 and 5 are two factors of 50, but 10 and 5, none of those numbers are perfect squares. 5 to 3, 25 times 5. No, that doesn't give us 50. 25 times 2, correct. 2 and 25, 2 and 25. 9 and 16, that does not give us 50. You need to multiply them. So how I can write square root 50? I can say square root 2, square root 25 times 2. Now, in this case, I did not change the value. Okay, I did not change the value of 50 because I'm still writing this is still true. They are still equal. Okay, 50 is equal to 25 times 2, right? If you have a question, I see a raised hand. If you have a question, I'd prefer you ask it in the chat or in the Q&A, or in the YouTube chat. Q&A is private, by the way. It's anonymous if you don't want anyone to see your question. Okay, so I haven't changed it. However, right, if I use surd rule number 1, remember it says that square root A times square root B is equal to square root AB. So if I work backwards, I can go to that. So square root 25 times 2, I can write as square root 25 times square root 2. Okay, and 25, I can actually square root it. That is the reason why I chose a perfect square, because the perfect square, I'll be able to simplify it and I'll be able to take out that square root when I do this rule. So now square root 25 is 5. I'm left with 5 root 2. Okay, so 5 root 2. Let's do another example. Let us do square root 27. Sorry, just give me 1 second. Okay, so square root 27. Now, okay, because not both have to be a perfect square. Just one has to be a perfect square. So someone asked, why did I use 2 if it's not a perfect square? You just have to write it as a product with one of its factors have to be a perfect square, not both, just one. You wouldn't be able to write it as a product with 2 perfect squares. Okay, so let's look at 27. All right, give me factors of 27, and one of its factors must be a perfect square. Nine and 3, correct. All right, so I can write this as square root 9 times 3. Again, I haven't changed the value of anything. Then I know the third rule. I can separate it into square root 9 times square root 3. Square root 9 can be simplified as 3 times root 3. Last one. Yeah, let's do 80. How can I write 80? Okay, 4 and 20, what else? 10 and 8, okay. So the reason you cannot choose 10 and 8 because neither 10 nor 8 is a perfect square. One of your factors has to be a perfect square. (16 and 5), okay. So generally, 40 and 2, if you look at 40, if you look at 2, none of those factors are perfect squares. 2 is not a perfect square. 40 is not a perfect square. Again, 10 and 8, 10 is not a perfect square. 8 is not a perfect square. 20 times 2, that does not give us 80. 16 and 5. So ideally, what you want to choose is the highest possible factor that is a perfect square. The highest possible factor that's a perfect square. But you don't always have to, right? So let's take 20 and 4, for example. We can see that the perfect square 4 goes into 80, but we also know that some people said 16 times 5. So we also know that 16, which is a perfect square, can go into 80. Now, let's see what happens when we choose 4, because maybe it's a bit easier to get 4, right? So I'm going to write square root 80 as 4 times 20, square root 4 times 20. Thereafter separated into square root 4 times square root 20. And square root 4 can be simplified. Square root 4 can be simplified to 2, and we're left with 2 root 20. Okay, but now you will notice that 20 I can also write it with a factor of a perfect square. I can also write it with a multiplication, a product with a perfect square, right? So I can get 2 root 20, okay? However, I'll notice that 20, I can still write it, like I said, sorry, I can still write it with a factor with a perfect square. What perfect square goes into 20? Okay, correct, 4 and 5. So I can do 4 again. So I can say 2 times square root 4 times 5. I haven't changed the value. I know that I can write this as square root 4 times square root 5. Okay, all multiplied by one another. And then 4 can change into 2 square root 5. So you get 2 times 2, which is 4 square root 5. Okay. However, if I had just used, instead of 4 times 20, if I had just used 16 times 5, I would have gotten square root 16 times square root 5 is equal to square root 16 is 4 square root 5. So you've gotten the same answer, just in one less, a few less steps. Okay, so just keep that in mind. It's not important. It's not mandatory. It's not compulsory to get the highest. But if you get the highest, it's just going to make it easier. Okay, cool. So that's simplifying surds, right? Let's look at some other examples. Let's look at this example. Simplify square root 147 plus square root 108. So what you can do is you can sit with your surds, like write them down. 1, 4, 9, 16, 25, 36, 49. Right, you should know at least your first 12 squares. 8 times 8, 64. 9 times 9, 81. 100. Okay, and so on, right? So let's do this. Try and tell me the highest possible factor of 147 that's a perfect square. The highest possible factor of 147 that's a perfect square. Forty-nine and 3, 49, 14 and 2. 14 and 2 is 28. Oh, no, sorry, you're saying 49 and 2, 49 and 3, not 14, 49. Okay, so you can say 147 divided by each of these, and you'll come to that it's 49. Okay, so square root 147, I can write as 49 times 3. What about 108? How can I write 108 with a factor that's a perfect square? Or rather, what's the biggest factor that's the biggest perfect square factor of 108? Two and 3. 23. 36 times 3. Okay, you can even choose 9. Right, 9 is a perfect square that goes into 108, but it's not the biggest. Okay, 36 is the biggest. So you can write this as 36 times 3. Now it's easy to simplify. Simplifies to square root 49 times square root 3 plus square root 36 times square root 3. So this becomes, because 49 simplifies to 7 root 3 plus this simplifies to 6 root 3. Okay, now we have like terms, right? Surds up. You can treat them like variables. So we have 7 plus 6 root 3. This simplifies to 13 root 3. Cool. Hope that makes sense. Simplifying surds. Okay, this question was silly. I don't even know why I put it there. But they're basically asking which root of 16 gives us 2. It's actually a 1-mark question. The cube root of 16 would give us 2, I believe. 2 times 2 times 2. No, it's like the 4th root. So basically, you just got to try to say 2 to the power of like 4, for example, until you get 16. Okay, and it was actually 2. So in this case, it was actually the 4th root of 16 that gave us 2. Why? Because 2 to the power of 4 is equal to 16. And in this case, when you take the 4th root of everything, you end up with 2 being the 4th root of 16. So therefore, x is equal to 4. Okay, but yeah, silly question. Doesn't really relate much. I thought it was the third question. Nevertheless, let's move on. Okay, so exponent rules, surd rules, really important, right? I would maybe what I'll do is I'll leave some questions if I get time. I will leave some more practice questions for you guys to practice. Surds are not so common in your guys' papers from what I remember, but however, you still do need to know the rules of it. And it's good to know them because they can ask a random question and they're not so difficult, right? We mainly use the rule number 1. Okay, so again, in your own time, you need to practice past papers nevertheless, right? You need to use past paper websites which have the questions, it has the memos, so you can practice them. Maybe your school gives you past papers, you need to be practicing them and looking at the memos either way. Okay, so let's just go through. We're going to start with equations and inequalities. We're going to do simultaneous equations, but let's just go through some reminders quickly. Linear equation, an equation of degree 1 with an equation of degree 1 with at most 1 solution. Okay, so when we say degree 1, it basically means that the highest power of the unknown is 1. Highest power of unknown, which could be x, could be y, is 1. Okay, so we're talking about x, y. As soon as it's x squared, that's not linear. Okay, the highest power is just 1. Okay, distributive law. Okay, distributive law states that when we have a open brackets b plus c, this is equal to ab plus ac. Okay, I'm sure we remember distributive law. The monomial factor is distributed or separately applied to each term in the binomial factor. Like terms that have the same variables in power. So for example, 5x plus 6x, these are like terms and I can add them. I get 11x. Even if I have something funky like 6x squared y plus 7yx squared. Okay, so remember the commutative property of multiplication, I think it's called. The order in which you multiply doesn't matter. So x squared y is the same as yx squared. Remember, this squared is only for the x. Even this squared is only for the x. So these are the same variables. So when I add them together, I get 13x squared y. Okay, those are like terms. Quadratic, so unlike terms, obviously, they don't have the same variables. And even if variables have different powers, they would not be regarded as the same. Those would be unlike terms. Quadratic equation, an equation of the second degree. When we say second degree, we talk about the power being 2. So example, x squared, as opposed to just having x. Okay, degree of the equation, it's the exponent of the highest power to which that variable is raised in the equation. Okay, we spoke about that. Constant term is a known or fixed value. Basically, anything that doesn't have a variable, it's just a number. Okay, we can call that the constant term. Coefficient is a number used to multiply the variable. Okay, so I'm sure we're familiar with this. For example, 5x squared. All right, this is my coefficient. 5 is the coefficient. This is the exponent. This is the base, just for some revision for equations and inequalities. Inequalities greater than, so this is less than, greater than. Remember where the pointy part points towards is always the less than sign, and then the other open mouth side is greater than. Two values are not equal, fractions and 0. So in fractions, we have the numerator on top of our little symbol thing and the denominator at the bottom. So 0 divided by x, meaning 0 divided by anything, is equal to 0. Okay. But anything divided by 0 is undefined. Okay, someone says, isn't your variable? Yes, true, correct. Technically, yes, we would refer to this as the variable in most cases. That's the unknown, correct. Okay, alternatively, the base of the exponent, but in this case, it will mainly be referred to as the variable. Okay, multiplications of sign. This is, of course, very important, right? Negative times a positive is a negative. I don't know, I didn't give all four. Let's start off with positive times a positive. This is a positive. They had negative times positive. I'm going to do positive times negative. It doesn't really matter. We're still going to get a negative. However, so the negative positive is a negative. When you do negative negative, you get a positive. Okay, so multiplications of sign, very important to understand. Let's talk about equations and inequalities. The first thing we're going to discuss is simultaneous equations. I'm guessing most of you guys are done with this topic. Tell me, is this the first time you're doing simultaneous equations, or have you been doing it since grade 8 or grade 9? First time. I think most people it should be their first time. Since grade 9, did it last week. It's my dad, yo. Last week, first time, we don't do something last. Okay, cool. So most of you are doing it for the first time, which makes sense. Since grade 8. Okay, cool. Okay, so nevertheless, let's continue. Simultaneous equations. Simultaneous means at the same time. So we are solving for these equations at the same time. We're solving for two variables at the same time. Determine values that will satisfy both equations simultaneously. Substitution. Okay, so let's look at example 1. Okay, now in simultaneous equations, you have two unknowns, x and y. X and y. So in both equations, you have two unknowns. Now, in algebra, in equations, when you want to solve for two unknowns, you need at least two equations to solve for them. Okay, you need at least two equations to solve for them. If you do not have two equations, you can't solve for them. And when you have one unknown, it requires one equation. Two unknowns requires two equations, and three, and so on, right? However, so in this case, we have two unknowns. So we are going to utilize simultaneous equations to solve for these two unknowns. So, okay, since it's your guys' first time, do I have steps? No, I don't have steps. It's fine. You guys can just follow this. Your first step, okay, I'll write out steps, not now, but I have a list somewhere. I'll copy it and put it in here. But we'll briefly write it, okay? So your first step, right, is to isolate one of the variables. Isolate, meaning leave it alone. Make it the subject of the formula. Isolate one variable. So we call this equation 1. We call this equation 2. Equation 3 is going to be the rearranged equation, which we isolate one variable. Choose the easiest one to isolate. Which one do you guys think is the easiest one to isolate in equation? Should we use equation 1 or equation 2? Which one will be the easiest to isolate? Just tell me, equation 1, xy, or equation 2, xy? Okay, I agree with you guys. Okay, we could use 2 technically. Okay, but if you want to talk about the easiest, you'll see why we could use 2. But 1, you want to choose the easiest one. And in this case, it's 1. Why 1? Because you want to choose the equation. Actually, because you're isolating a variable, you want to choose the variable that has the least complications, that has the least attached to it. And a variable that's completely alone is actually ideal. Okay, so in this case, we have x alone and y alone. What do I mean by alone? It doesn't have a 2x attached to it. Okay, maybe you won't do it in this grade, but sometimes you have 2x squared plus y, for example. In that case, it has a squared attached to it, so that's not good. So you want to choose the easiest one, and the easiest one is the most alone one. Let's choose x. Okay, you could choose y. You see, you could even choose that y because it's alone. Okay, but let's just choose equation number 1, and let's choose x. So I'm going to choose x, and I'm going to formulate my third equation called the rearranged equation, where I'm just basically rearranging this. So if I leave x alone, I take y over, it becomes 8 plus y. Okay, I hope that makes sense. Now I have my third rearranged equation. Okay, once I've isolated one of the variables, I choose the easiest one to isolate. So that's isolated. You mean I formed equation 3, the rearranged equation. Okay, step number 3 is to substitute our rearranged equation into the other equation we didn't work with yet, which in this case is number 2. So substitute number 3 into number 2. So here's number 3, there's number 2. So wherever I have x, let's choose a different color. Wherever I have x, I'm going to put x plus y. Wherever I have x, instead of writing x, I'm going to write x plus y because x is equal to x plus y. We know that. When are we going to start? Strigs, most likely next week. Let's try and finish everything today, then we can start next week. So in equation number 3, right, x can be left alone and we get 8 plus y. So now, wherever I have x, I'm going to substitute it with 8 plus y. So I substitute number 3 into number 2. So 2 open brackets, always use brackets when you're substituting. Oh, sorry, x plus y. Is equal to 10. Sorry, plus another y is equal to 10. Okay, so I've substituted number 3 into number 2. Wherever I saw x, instead of writing x, I write it as 8 plus y. And now you can see, because I've expressed x in terms of y, we have one unknown now in this equation. One unknown, it is y. So when we have one unknown, we simply need one equation to solve for it, and that's what we're going to do. So I'm going to distribute this 2. I get 2 times 8, which is 16, plus 2y, plus y is equal to 10. Keep the 2 y's here, I get 3y, take 16 over, I get negative 6. Divide both sides by 3, I get y is equal to negative 2. Okay, since I now know the value of y, whenever you know the value of y, so I'm going to say solve for variable, right, which is what we've just done. So that's step number 4. Substitute the value for the variable that we just solved. Substitute the value of the variable into which equation? Into equation number 3. Always, the rearranged equation is always the easiest to sub it in. Okay, so I'm going to take y and sub it into the rearranged equation. Why am I specifically, it's not compulsory to use the rearranged equation number 3, but why am I specifically telling you to do it? It's because it's simpler, like x is already alone. Okay, x is already alone, so when you sub in y, you're straightforward going to get a value for x. So now to solve for x, you're going to say rearranged equation. You're going to say x is equal to 8 plus minus 2. X is equal to 6. Okay, that makes sense. 1 second. So that's solving for simultaneous equations, solving for two variables at the same time. Step 1, isolate one variable, choose the easiest one to isolate. Step 2, formulate equation number 3, the rearranged equation. Okay, that's you're isolating. When you're isolating one of the variables, you're actually forming the equation. Okay, step number 3, substitute that new equation that you formed, number 3, into substitute that new equation, number 3, into number 2. Solve for that respective variable. Number 5, substitute the value of the variable you just solved into equation number 3, which is the rearranged equation. Number 6, solve for second variable. Okay. Did we let x is equal to 2 to the power of 3? No, we didn't. Are you talking about the same question? Okay, let's have a look at this. Example number 2. Okay, is everyone fine with example number 1? Cool. So in example number 2, I'm going to label. Okay, I don't understand your question, eh? Did we let x equal to 2 to the power of 3? In example number 2, I'm going to let this be 1 and this 2. Tell me, where should I isolate my variable? In equation 1 or in equation 2? Definitely 1, okay, because 2 is complicated, okay, and in 2, it's going to be tough to leave x alone. You're going to have to do LCD and this and that, right? So this question, by the way, it's from November 2022, so it's from last year's November paper. So what's step number 1? Isolate one of the variables. Step number 2, formulate the equation number 3. So I'm going to create equation number 3. How am I going to create equation number 3? I'm going to create equation number 3 by isolating one of the variables. In this case, I chose equation number 1. So I'm going to leave x alone, and I'm going to get 4 plus y. And that's going to formulate equation number 3 for me. Okay. Step 3 says sub 3 into 2. So I'm going to take 3. So generally, the one that you are leaving, the one in which you have chosen the variable, you want to label it as 1, and all the rules will make sense. Label the one where you're going to leave it alone, label it as equation 1. Then the other one is 2. Formulate number 3, substitute number 3 into number 2. So what do you mean by substitute? Wherever you have x, you're going to put not x, you're going to put 4 plus y. In that way, you are creating an equation with only one variable, that is y. Okay, so let's sub it in. So sub 3 into 2. Okay, so x is right there. Instead of saying x, I'm going to say 4 plus y over 5 plus y over 2 is equal to 5. What do I do from here, people? Yes, correct. 3 letters LCD. You have to do lowest common denominator, because this is what? This is fractions. Adding of fractions. What is my LCD? So remember, my options are 5, 2, and technically 1. Obviously, 1 will go into anything. 10, excellent. Right, this one is easy. It's 10. So the best way to solve LCD, you make them all 10, right? Plus is equal to, so that over 10 plus that over 10 plus that over 10. Now our denominator changed, okay? From 5, how did we get to 10? Our denominator changed. We multiplied by 2. So what we then have to do is take the numerator and multiply that by 2 as well. Whatever we do to the bottom, we do to the top. Let's look at this guy. How did we go from our old denominator to our new denominator? We multiplied our old denominator, which is 2, by 5. So how do we get our new numerator? We multiplied by 5 as well. Okay, so here we have 2 open brackets 4 plus y. Here we have 5y. How did we get from 1 all the way to the new denominator of 10? we multiply it by 10. So what we do to the denominator, we do to the numerator, multiply that by 10, we get 50. In an equation, in a what? In an equation, yes, you can do LCD before you sub, correct. You can do it before you sub, 100%. In an equation, okay, whenever you have the same denominators across all terms, all right, either side of the equation, you can say goodbye to the denominator. Because you're dividing everything by 10. If you get rid of the 10, same value. Okay, so let's open up. I'm going to get 8 plus 2y plus 5y is equal to 50. 7y is equal to 42. Y is equal to 6, I believe. Someone can correct me if I'm wrong. Okay, so we use LCD to solve for y. Now we've done step 4 where we solved for, let's just call it first variable. Okay, so now we solved for the first variable. So once we solve for the first variable, we can substitute that value of that variable into the rearranged equation. So let's do that, right? We just solved for 6. So I'm going to take my rearranged and I'm going to formulate x is equal to 4 plus the new y value we just solved for 6. So x is equal to 10. I hope that makes sense. I'm pretty sure also you've been taught, like maybe they teach you different ways to solve it, but I would recommend using substitution. It is indeed the easiest way to solve for simultaneous equations. Okay, so this method is called substitution. Okay, I hope it makes sense. Solving for 2 variables using 2 equations. Okay, let's look at simultaneous. How did we get 7y is equal to 42? Okay, how did we get 7y is equal to 42? Good question. I said 2 plus 2y plus 5y. Then I needed to take the numbers over. So I got 50 minus 8. 50 minus 8 is 42. 2 plus 5 is 7. Y. Thanks for that question. Okay, and then we solved. We said that. Basically, now, okay, we divide both sides by 7. 42 divided by 7 is indeed 6. Okay, let's have a look at this. Simultaneous equations, word problems. Okay, so determine the values of x and y if the quadrilateral is a rectangle. Any idea what can I do? Someone tell me. What can I do over here to solve for this? Determine the values of x and y, okay, if the quadrilateral is a rectangle. Terms like, okay, but not really. What would we do? Add all up and should equal to 180 along the geometry lines, but not 100% correct. Group like terms, new people. So you guys want to add it, okay? So we don't know the length, okay? We don't know the length and the breadth, okay? Size equal each other. That sounds more correct, okay? When you add up and equal to 180, firstly, you should add the angles up and they add up to 360. So if you had to add this and that and that and that, that would add up to 360, okay? However, the sides, we don't know the value of them, okay? Anything else? No, we're not adding like terms or anything like that. We need to use our understanding of the properties of a rectangle. Properties of a rectangle state to us that opposite sides are equal. So that side is equal to that side, and this side is equal to that side. So I can create equations. 2 sides would be 54. No, so the length of this is 54. So the length of that should also be 54. So actually, I can now state that 2x plus 14, I know for a 14y, I know for a fact is equal to 54. Why do I know that? Because it's a rectangle and opposite sides are equal. And this side says it's 54, that side says it's 2x plus 14y. So they have to be equal. Okay. Then I can also say that 4y is equal to 2x. I know that for sure. 4y is equal to 2x. Okay. So now I have two equations, two unknowns. I will utilize simultaneous equations. Okay, so that's the usage of simultaneous equations applied in word problems. Okay, so that's how you have the understanding that, okay, listen, shucks the time. Yeah, let's finish this question because we did finish a bit late. Let's finish this question and then we'll end there. For those of you who need to leave, you may leave and then continue the recording later. For those of you who can't stay behind, please do stay behind. Let's finish up this question. We're going to end slightly late. I just want to alert the next class that we are running slightly late. Okay, thank you for the reminder. But yes, okay, so that's why you need to have that understanding that, okay, if I have two unknowns, I need two equations to solve it, or rather also, if I have two equations with two unknowns, okay, I can use simultaneous to solve it. So you're not just limiting your understanding of simultaneous equations just to when they say, please solve for the following simultaneously. No, you can use your brain a little bit, and in different questions, you can use it as well. For those of you who take physics, you will notice, maybe not yet, but especially like once it comes to grade 11, 12, you will be dealing with simultaneous in physics. So the better you understand it now, the better it's going to be for you in physics. So now, again, I've created these two equations. And I notice, okay, I have two equations, two unknowns. I'm going to utilize simultaneous equations to solve for these. So I'm going to use the same method. Someone tell me which one I should use for one and which one, okay. Which one, in which equation should I use to isolate one of the variables? Okay, one person says 4y is equal to 2x is easier. Does anyone agree or disagree with him? Two, which I'm guessing you're referring to 4y plus 2x. Use one, use two. Use one, use two. Okay, so technically you could use either. I would probably suggest using the second one. Okay, just because if I have to use this one, right, let's do it. Okay, let's leave x alone. So I'm going to have 2x is equal to, I take the 14 over, I'm going to get 54 minus 14y. Okay, then in order to leave this x alone, I'm gonna have to divide both sides by 2. So I'm going to have x is equal to 54 minus 14y over 2. And I can simplify this if I want, but at the end of the day, this is what it is. So it's a bit complicated. Can you turn the second into 4y minus 2x is equal to 0? 100% you can do that. You definitely can do that. You can take this over and say 4y minus 2x is equal to 0. Okay, but you'll see there's no need, right? So I'm not going to do this. This answer was a bit complicated. Let's try the other one, right? Let's try 4y is equal to 2x. I'm going to leave y alone. So actually, because I'm going to isolate using this one, I'm going to call this equation 1. And I'm going to call this equation 2. Just so the rules make more sense, subbing 2 into 1 and 1 into 2 and all of that, right? So when I leave, in order to leave y alone, I have to divide both sides by 4. 0.4 cancel there. I get y is equal to 2x over 4. I can actually simplify that. Okay, I can say y is equal to a half x. Because 2 over 4 simplifies to 1 over 2. And then you can always, whenever there's a multiplication on top, you can write it separately. Or you can even leave it as, maybe what's actually better is x over 2, which is basically 1 times x over 2, which is basically a half x over 2, or equal to the same thing. So we can say that y is equal to x over 2. Okay, now that's slightly less complicated than the other one that we had. So now I have a value for y. Now, wherever I see y, I will substitute x plus 2. So I'll say 2x plus 14 x over 2 is equal to 54. Okay, now I have I have a single unknown, which is just x, okay, and a single equation, so I can solve for x, right? So I can say 2x plus. Now, how do we multiply these? Someone tell me, what would this simplify to? 14 times x over 2. Basically, multiplication of fractions. How do you multiply fractions? I think we've covered this when we did equations. Seven, I guess, true. But what you want to do is you want to multiply fractions in a straight line. So you want to express 14 as a fraction as well. So 14 as a fraction is just 14 over 1 times x over 2. So what you're going to do is you're going to multiply in a straight line always. Always, always, always. Fractions, you multiply in a straight line. Add or subtracting fractions, LCD. Okay, so now I just multiply across numerator, numerator, denominator, denominator. I get 14x over 2, which is equal to 7x. Okay, so now I know that this simplifies to 7x. So 2x plus 7x is equal to 54. This is 9x is equal to 54. Divide both sides by 9. I get x is equal to 6. Now substitute the variable into the rearrange equation, which is number 3. Sorry, we should have called this guy number 3. The rearranged. It will be the easiest to substitute into the rearranged. I'm going to get x is equal to, y is equal to x over 2, 6 over 2. Y is equal to 3. Okay, hope that makes sense. Solving simultaneously. Here's an example you guys can try on your own. Yeah, go for it. And there's a hint. I might get rid of that hint. Let's see. So simultaneous equations using what? Okay, so I hope you guys understand. I will thank you guys so much for attending. I hope that it was beneficial. I will see you guys next week at the same time. Okay. Yeah, good luck. All the best. Thank you guys. Jazakallah khair.